Okay, Assalamualaikum. So we continue for the third characteristic for the roots that we call as the complex roots. Okay, so this is the general solution, and this is how we can solve for the roots. Okay, we can using the m equal negative b plus minus b square minus 4ac divide by 2a, or you divide here by 2a and by 2a. So similar for the real and distant roots or real and equal roots. So the first step, we need to change ataupun substitute the ODE, or we need to form the auxiliary equation. Okay, we need to form the auxiliary equation. So this is the equation. So this is the equation. So they given this second ODE. So here is the initial condition that you need to use in the general solution. So they are the y and they are the y prime. So general equation is the y, and then you need to differentiate general solution to find the y prime, and then you need to substitute this value, okay, this value into the y and this value to the y prime to obtaining the arbitrary constant, to find the arbitrary constant. Okay, now we need when we start again. So this is the second ODE. So you need change y double prime as the m square plus 6 y prime as the m. So 6m, y is the 1, 13 multiply 1, so you get the 13, so that equal to 0. Okay, this is the first step. Okay, change ataupun to form the auxiliary equation. Second step, so you need to b square minus 4ac. Okay, to check this one, either the roots is the complex, real distant, or real equal. Okay, so if the answer equal larger than 0, so that means the roots is the real and distance. So equal to 0, that means the roots is the real and equal. Less than 0, that means the root is the complex. Okay, so you need to check here. So b square is the 6. Okay, 6 square minus 4ac. Okay, 4 multiply a is the 1, multiply c is the 13, so you get the 52. 36 minus 52, so you get the answer is the negative 16. Negative 16 is the less than 0. That means the root is the complex. Okay, less than 0, that means the root is the complex. If the equal to 0, real and equal. If the larger than 0, is the real and distant. Okay, sorry, less than 0. So you can use this formula to find the general solution. So before we get this one, we need to find the roots m1 and m2. So you can use this formula to find the roots. So you use this one. So this one is split. So you get, because you want to form in this form. Okay, so m equal negative b divided by 2a plus minus b square minus 4ac divided by 2a. So here you can get negative b is the 6. Okay, negative b, 2a is the 1, so a is the 1, plus minus, so this one you already solved. Okay, this one you already solved, you get the negative 16. So here have the negative 16. So when you remove the negative 16, so you need to find the imaginary I. So divide by 16. Okay, 2 multiply a is the 1. So your final answer is the negative 3 plus minus 16, square root of 16, the 4 divided by 2, you get 2i, imaginary. So you already form in this m1 and m2. So you can plug in this value into this general solution. So you get the y equal exponent alpha is the 3. Okay, this one alpha is the 3. So negative 3x. Okay, a cos beta, look here, so beta is the 2, 2x. So plus b sine 2x. So you complete for your general solution. So here, so you repeat here again to find the particle quotient. So the given is gs in the term y, so you need to find the y prime. So here you need to twice. So when you solve here, so y equal exponent negative tx a cos 2x, okay, plus exponent negative 3x b sine 2x. So here have the x, so this one you need to solve using the product rules. So you find y prime, so this one product rules, okay, product rule. So this one one also x, so you need to solve for the product. So you have the two product rules you need to complete to find the y prime. When you find the y prime and then you plug it in this value, and then you can get the two equation, one equation, second equation solved as the simultaneous equation, and to determine for the a and b, the arbitrary constant, and then you solve for you find the value of the a, b, substitute this general solution, and then you can get the particular solution. That's all. Thank you.